you could train some extension agents, but these days there aren't enough of them, okay? So it seems like how we're going to scale this up, okay, is we have to automate it. We have to create a way to automate the design and analysis of these trials. And because what we used to do in 2016 and even now is we did a lot of emails. And when we did 6 trials in 2016, that was roughly doable. We would send emails and please send a boundary file. Oh, this is wrong, or we need another A/B line because yours is pointing the wrong direction, and we do 40 of those per farm, and it was work for everybody and could be difficult. So that was fine. It wasn't impossible, but it's not scalable. So we need something else. First designed the trials, my brother and a guy named Ron Milby, they wrote a computer program that went in with Esri software and was designed for researchers. The idea is some agronomist at University of Madrid would want to run some field trials, some big field trials in Spain, and that person would use this software. So that wasn't particularly user-friendly either, but my brother was the one who came up with this idea. Okay, so then what happened was once the trial was run, we had to get their data. Okay, and so you can mail a shape file to somebody that has a boundary, because the boundary is just, a few 20 points, longitude, latitude points, right? And you can even send a trial design to them because that's 200 polygons, each one with 4 points. That's all doable. But once you start getting as applied data, which I'll show you later, you can get 100,000 observations and it gets too big to email. Okay, so then either you got to put things in a Dropbox, but in 2016 and 17, not all farmers knew how to use a Dropbox. And so what you do then is you have Bob Dunker get in his truck and drive out to the farm. Bob, did you ever do that? Drive out to the farm with a thumb drive So that was, drive up 89 miles each way and get the data. So that's not scalable either, but you can imagine. That's why we started giving farmers $1,000 when they got us our data back. And then we in the Ivory Tower wrote some report by hand. I wrote the reports with Microsoft Word and made a bunch of diagrams and stuff and sent the report back to them. And then we met with them and had PowerPoint discussions and all like that. And that was great, and we learned a lot, but it wasn't scalable. Okay, you can't do 10,000 trials per year like that, okay? So there's just not enough researchers or extension personnel to work with tens of thousands of farmers. So there's a bottleneck. So what do we do? Okay. Our strategy is to create a cloud-based system that we're calling a cyber infrastructure that will allow on-farm precision experimentation to flourish through private markets. In other words, there are enough crop consultants and agronomists and professional farm managers out there that each one can work with yay many farmers, and that's doable. Okay, so we're trying to create a system that will be aimed at co-ops, ag retailers, crop consultants, etc., and they will work with the farmers. Okay, which means that we have to make a system that's, you don't have to let your grandpa be able, or me be able to use it. Okay, but it has to be something that you can learn in a few days or a day at a training session. We want something very user-friendly. So that's what we're trying to create. All right. Now, there's two things here. One is the guts. One is there have to be sophisticated computer programs that figure out how to clean data, that figure out what's the best way to analyze data. Should we use various statistical regressions? Should we use artificial intelligence? Should we use crop modeling? And the answer is we're throwing everything at that. We have computer scientists, we have statisticians, we have all sorts of people working to do the research it takes to understand how to turn this kind of data into good management advice. That's one thing. So that guts, that's really the hard part. But there's another hard part, which is to bring that to people in a way that they can use it.
Okay,
so this is kind of busy, but I want to kind of walk you through it a little bit to understand what we're trying to do. Okay, this thing starts with a farmer and a consultant sitting together at probably a bigger computer than this. and they're doing stuff. And the first thing they need to do is they have to be able to design a field trial. Okay. And so we have, and Brittany will show you this later this afternoon, we have some software that is pretty easy to use. It's in a very rough form, but we have software where people with very little training can learn how to design these field trials. Okay. That field trial data has to go into a raw data set along with field characteristics data, weather data, and then that has to go into a data processor that creates analyzable data. We have this. We have the guts of this. We can analyze this data. We have a very nice way to process data. So that's all automated. Okay. It's automated, but it's not, there's no interface for it yet. Also, this data set right here, we don't have that in the kind of system we need. Keith will talk to you about this tomorrow, but we're going to base things on an Oracle data set so the Russians can't steal the data, et cetera, et cetera. We need something that can process lots of data and very efficiently handle data. So we need a real data set, not something in box. So that's a big deal, and Keith is handling that. And so we need to process that data. We have to have something that it goes into a database. And then from there, the process data has to go to some kind of analytical engine that does stuff and comes out with a decision tool. Then with that, we want something that the farmer and the consultant can sit down with and work with, okay, to help make decisions. In with that is communication and extension. We imagine something where people can talk to each other. Farmers can talk to each other about their experiments and what they're thinking, or they can complain, so that there can be communication in this. So that's the cyber infrastructure, and now I'll try to give you a little detail. Oracle is a corporate sponsor of ours, and what we're doing is going to be on the Oracle Cloud. And we're making progress in that, for sure. All right. User interface, you'll see a little of this. This is obviously not the user interface, but login, username, password on the Oracle Cloud. Every trial will have its own number, and every trial will be connected to a field, and every field will be connected to a farm, and every year, and all that will be in the way database people do it in an efficient way. Okay. All right. Major things, major sections of components of this cyber infrastructure is you got a data component. And that's huge because everything has data. Everything has to go back and forth. Everything's connected. Trial design and implementation. Then you have a decision tool. And then you have communication. So these are kind of the four components of that cyber infrastructure that we're trying to create. Okay. What might this look like? Well, Keith has developed some stuff that already looks like this. If you go onto myjohndeere.com and you have an account, it will show you a map of where all your fields are. And I've seen these where farmers have, big farm, 100 fields, et cetera, et cetera. We're looking for the same kind of thing. And we're looking for a data set. We're not trying to give you a My John Deere data set where it tells you everything that ever happened on your farm. We are being focused. We're going to focus on experimental data and on-farm precision experimentation. There are other ways to deal with farm data that other companies have already developed, and we don't need to compete with them. George Murphy is my grandfather, who was a farmer. All right. But what we do want to do is to be able to visualize this data in lots of ways. And we have some people who are experts in data visualization. There are a lot of things you can imagine. How can I look at this? How can I understand it? Well, there are people who think about that all the time, and they're working on the project. Okay. Of course, visualization of characteristics data. You can get this kind of thing from various pieces of software, but it might be helpful if when you pulled up your field trial and you looked at the results, you could also pull up a soils map with it, or a map of slope, that kind of thing. All right. We need fast ways to query this data, download various kinds of data. Maybe it's 2029 and you thought, didn't we run a trial back in 26 and see something like this? Well, you should be able to query that and figure out where it went and where's the trial and where's the information, et cetera, et cetera. And you should be able to get various kinds of maps, et cetera. Okay. Here is the trial design implementation software. We have an early draft of this. You'll see it very soon. We haven't hooked this up to the Oracle system yet, but we are working on that for sure. All right. It's very possible that we may, I don't want to redo my John Deere, or this is Our Avant, which is an Argentinian and Spanish company that has websites where you can look at, you can go here and you can look at different kinds of data, et cetera. Well, my extensions, I would like to build something that can feed into these things. So like if you were a customer of Our Avant or a customer of mine on John Deere and you're a consultant, you could go into what we're doing with what they're doing already. Okay? It wouldn't just be completely independent. Okay. And here's key. We want this to be interactive. We want to say things like, well, I'll show you that in a second. Okay. All right. This analytical engine, this is, I think, 100 years of research. I think people will learn more and more over time. I think the way we're creating this new data is going to change a lot in how much data there is in the world and how agronomists do what they do. And so it's hard. Then how do you get information out of that that's worth something? And the answer is, well, there's a lot of questions. The one question that Xiaofei just talked about, what's the best way to design a trial? That's one of 1,000 questions that you would want somebody to think about real hard for a long time. And they'll do that over time, is my hope. All right. Decision tool, I can imagine output like this, okay? If you've run trials for a few years, like Bruce said, the farmers eventually want to start making money off what they've learned. They don't want to run a trial year after year after year. So one idea, and we have some computer scientists thinking about using artificial intelligence to try to do this optimally, is you could think about using some of the things and putting a prescription in that comes from past year's data, right? But then in other places, you just use the old prescription. In other words, what the farmer would do without you. Okay, so you can imagine a system that over time tries to figure out how much of this trial do we think we should experiment on this year, and how much should we just use past what we learned in the past to do. And you'd want to have a system where the crop consultant and the farmer are always also farming information. Now that sounds hard. It probably is kind of hard, and farming is for smart people these days. So that's what's going to happen. All right. We don't want to just, however, put out a prescription. There you go. There's what you're doing. We don't want it to be a black box. We want it to be interactive and dynamic. And that's not easy to get a computer to be interactive and dynamic, right? You go onto your insurance website and you get a bot that is trying to chat with you, and it's not a very good person. So you can imagine how difficult this would be. Nonetheless, we would like to be able to ask questions like, what if it rained more second week in June? How does this map change, right? What if the price of corn were higher? What if it were $1 higher? How does this mass change, okay? Risk tolerance. What if I'm willing to take a little bit more of a risk? How would this change? All right. And we want to have this be able to provide intuitive discussion of the results, which means that you've got to get agronomists and people who know how these things work to help take data and have reasonable interpretations of what's going on. We're trying to create a tool that consultants and farmers can use. They have experience with their own fields. They have they know a lot about agronomy. Well, then why in this part of the field did we see this result? And we want to provide them a tool with which they can think about that and come to their own conclusions. So we're not trying to just create some kind of prescription. Sure, that will be a thing. But we're trying to create a tool that 20 years from now will really help people do their job by mixing what they know intuitively with the data they generate from this cyber infrastructure. Another thing about this decision tool, and this is something I'm very interested in. We said farmers are gamblers, so this might be too much, but see if you can hang with me here. When we talk about those let this be the probability on this axis, right? This is nitrogen on this axis, and this is profits, not yield on this axis, right? And so that yield response function we're talking about, basically what it is it's a mean response function. It's what would happen on average, okay? But really, when you choose in area A, at site A, to put down 140 pounds of nitrogen, you aren't choosing that much profit. You're choosing a whole distribution of profits, right? That might be the average amount of profits, but you may get way more, you may get way less. And so the question is, let's see, on site B, what the computer's telling me is that, yeah, my profits aren't as high as over here at 200. My profits at 140 are not as high as 200 on average, but I really cut the variance down. And, my spouse really doesn't want to risk our money this year because we got to send a kid to college, et cetera, et cetera, et cetera, et cetera. And so you start thinking not just about profits on average, but you start thinking about distributions of profits. And that, of course, is going to depend on weather, and it's going to depend on climate. And then how do you bring weather and climate into these models? Well, that's, I think, where crop process models come in. Now, the question is, of course, your average person is not going to look at that and say, oh, yeah. So then how do you, without doing something this hairy, communicate these ideas of probability to people in ways that they can use and are useful? So that's all a matter of, we don't know how to do that yet. All right. In the communication part, I would like to have a forum, right? A public forum where there's places to discuss things and discuss things or be disgusted with things, talk to each other and saying, what do you see here? What do you see there? A lot of instructional videos, like some of what Bob showed you. We're starting to create these. How do I do this thing with DIFM? Well, here's a video. Results of the whole project. What's going on all over the world? What is happening? What are you seeing on the whole? Office hours. This will be mostly Hai-Ying. She'll spend about 20 hours a week just talking to people all over the world by email. Not really. Okay. Ask an expert, contest X, et cetera, et cetera. So part of this we want to have as a discussion, place discussion. So there's the whole cyber infrastructure again. Questions?